I want you to go through this and learn the technique of this problem one more time. Okay? Let's look at another problem. A 16-gram bullet is fired into the bob of a pendulum of mass 1.5 kilogram. When the bob is at its maximum height, the string makes an angle 60 degrees with the vertical. If the length of the pendulum is 2.3 meter, find the speed of the bullet. Well, here we can actually use the conservation of energy and conservation of momentum, and that is the way we're going to solve this problem. Now let me show you what this problem is talking about. You have a small ball of 16 gram, is that right? A 16 gram ball is fired into a 1.5 kilogram pendulum. This is the pendulum. It can move, is that right? It can swing. Okay. Now what I'm going to do is I'm going to charge my gun and I'm going to fire this ball into the pendulum and see what happens. There you are. The pendulum swung and now it makes an angle of 60 degrees with the vertical. You are given the length of the pendulum. What we need to figure out is the initial velocity with which this ball was fired. Now, if you notice, when the ball is fired, it has a velocity. That means there is an initial momentum, and with that momentum there is a collision. Now after the collision, the pendulum and the ball move away together. The momentum is conserved. The total momentum before collision equal to total momentum after collision. So we can now use the conservation of momentum here, and also once the ball hits the pendulum, the two together has a velocity, has a speed. That means this pendulum ball system will have a kinetic energy, and that kinetic energy is going to become potential energy when the pendulum climbs to a height. Now we're going to use the conservation of energy there. What's there? Well, it didn't work, did it? The pendulum refused to get stuck there. Let me try it again. There you are. The initial kinetic energy of the system became potential energy of the system. Alright, this is what we're going to use in solving this problem. Well, I have done a very poor drawing here. This is the pendulum of mass 1.5 kilogram and length 2.3 meter. We don't know the velocity of the bullet on impact. Let that velocity be v. There it comes and impacts. Now, mass of the bullet is 16 gram, that is 0.016 kilogram. Therefore, its initial momentum, P1I, initial momentum of the first object, that is the bullet, is its mass times its velocity, 0.016 v kilogram meter per second. Now the bob initially is at rest. The pendulum is initially at rest. Therefore its momentum initially is 0. The total momentum Pi is momentum of the ball plus the momentum of the pendulum bob, which is this quantity plus 0. That is 0.016 v kilogram meter per second. After the bullet hits the bob, they become a single system of total mass 1.5 kilogram plus 0.016 kilogram mass of the pendulum plus the mass of the little ball, and that is 1.516 kilogram, and moves away with a speed of Vf, a velocity Vf, so that the final momentum Pf is 1.516 Vf, and that Pf must be equal to Pi. Is that right? Now this is the Vf, the final velocity. Pf equal to Pi gives you this relation: 1.516 Vf equal to 0.016 V. Now we cannot solve anything from there because there are two quantities we don't know. So using the conservation of momentum, we got one equation. We will now go and use the conservation of energy to produce another equation. Let's do that. So this is the first equation: 1.516 Vf equal to 0.016 V. We can now find the Vf, the common velocity of the bob and the bullet, by using the conservation of energy. The kinetic energy of the bob and the bullet together immediately after the impact. You see, Vf is the velocity, the common velocity of the bullet and the pendulum bob immediately after impact. Therefore, its kinetic energy will be 1/2 m1 plus m2 Vf squared. And we know m1 plus m2, we don't know Vf. And that will be 1/2 times 1.516 Vf squared. This is the kinetic energy of the system immediately after impact. And that is 0.755 Vf squared. What happens after impact? With this kinetic energy, the bob climbs to a height h so that the string makes an angle 60 degrees with the initial position, as I demonstrated that to you. So this is now going to go and rise so that the string now makes an angle 60 degrees. There you are. And if this is O and this point is A, then in the triangle OAB, the length OB, which is the length of the pendulum, is given to be 2.3 meter. That's 2.3 meter. Now, therefore, we can find the length OA. You see, if this is 60 degrees, OA is the adjacent side and 2.3 is the hypotenuse. Therefore, OA divided by 2.3 is cos 60 degrees, and that gives us OA equal to 2.3 cos 60 degrees. That is 1.15 meter. Now, if this OA is 1.15 meter and the whole length of the pendulum is 2.3 meter, what is this distance? So this distance OA is 1.15 meter. Therefore, what is that distance? That is the height to which the pendulum has been raised, isn't it? When the pendulum is hit, it rises, and this is the vertical height h, and that h equal to the whole length is 2.3, the length of the pendulum. OA is 1.15. Therefore, that h is 2.3 minus 1.15. That is 1.15 meter. So the system has been raised to that height. What is the potential energy of the system? The potential energy of the system is the total mass m1 plus m2 times g times h, and that is 1.516 kilogram is the total mass, times g times h, the height to which the system rises is 1.15 meter. That is 17.1 joules. And this potential energy must be equal to this kinetic energy according to the law of conservation of energy. So using conservation of energy, you have the kinetic energy must be equal to potential energy. 0.755 Vf squared is 17.1. That gives me Vf equal to square root of 17.1 over 0.755. That is 4.8 meter per second. That is the velocity of, as soon as the bullet hits the pendulum and the bullet together move away with this velocity. Alright, let's now go back to our first equation. Which is our first equation? We have 1.516 Vf equal to, this is the first equation we have, 1.516 Vf equal to 0.016 V. That is the first equation we obtained using the conservation of momentum. Now we use the conservation of energy and obtain the value of that Vf. Using that, we can now find the V. V equal to 1.516 Vf divided by 0.016. And that is, using the value of Vf, we get that is 455 meter per second. And that is the velocity of impact of the bullet.